Hello guys, I'm back. In this video, I will teach you 5 Aspen Hysys fundamentals that chemical process engineers must know to do process simulation. My name is Jeferson Costa. I'm a chemical process engineer with expertise in plant design, and I teach students, graduates, and senior engineers how to work with chemical process engineering and plant design. To develop engineering documentation needed in plant design, most often the chemical process engineer will use process simulation software to do the heat and material balance of the plant. The main benefits of using a process simulation software is that you can get much faster results than if you use only hand calculations. However, you, as a chemical process engineer, must know and understand the fundamentals of the software that you are using. And in this video, I will share with you 5 related to the Aspen Hysys. Any process simulation you start, dependent of the process simulation software that you are using, you must define the fluid package of your process. And the fluid package is a combination of the component list and also the property package of your process simulation. The components available to be added to your component list depends on the data bank of your process simulation software. Different softwares from different companies will have different data banks, and eventually the same software but a different version will have different components available to be added to your component list. Here in Aspen Hysys, you have 2 options of data banks. For the standard data bank in Aspen Hysys, you just need to click on Add, but if you want to change the data bank available to you, you can click in the arrow and look for the Aspen Properties. These 2 databanks will give to you different options of components. Of course, that the pure components, the most known ones, is available in both of them. To start with the comparison, let's verify the interface of the standard Aspen Hysys databank. So if I click on Aspen Hysys, I will have this kind of interface with the selection of pure components or hypothetical solid. I can filter by family, hydrocarbon solids, and others options here to filter the components that is available in this data bank. And I can search based on full name, synonym, formula, or simulation name. In this case, I will just add water to let our life easier for others fundamentals that I will share with you. Based on that, as I have at least one component to my component list, the Aspen Hysys already converted my component list. But I am able to add more than one component list to my process simulation. So if I return to the component list folder, I am able to return it to Add, and now instead of choosing Hysys, I will choose Aspen Properties. When I click on that, you can see now that the interface for the component list is different. Now I need to search for my component instead of having a list of components. And I can do the selection based on the components or in hypothetical. In this case, I will use also water. So when I type water and click on enter, my component is added to my component list. So now I have the component list 1 and the component list 2. Why it's important to understand this fundamental in the process simulation software? When you are developing a process simulation, you must verify if the components that you need to your process simulation or to your process is available in the data bank of your process simulation software. If they are pure components, most often they will be available to you. But if they are not common components, eventually you will need to verify how you can add them to the process simulation in order that to get the characteristics of your components to your process simulation. Returning to the component list, now we have a component list where the source is the Hysys databanks and one with the Aspen Properties databank. And now we need to attach a fluid package to be associated with the source of your component. And what is the fluid package? As I told you, the fluid package is a combination of the component list. We already did the component list and also the property package. And the property package are specialized collections of methods for calculating the properties of components at a temperature, pressure, and composition of interest in your process simulation. So now, to find the property package, I need to go to the fluid package. And as I have in the component list, I can add a standard list of property package available on Aspen Hysys, but I can also use other source of information. For instance, the Aspen Properties property package available on there, and also the ConThermo. When you add a component list different from the Aspen Hysys databank, you have some restrictions. So let's verify. If I click in Hysys to add the property package, you can see that appears to me a list of selections. So I need to choose the component list that I want to associate this property package, because the property package plus the component list will become my fluid package. And when I click in the arrow, you can see that only my component list 1 that comes from the Hysys databank is available. I am not able to associate the property package available in the standard Hysys property package list with the component list that comes from the Aspen Properties. As we are dealing with water, I will choose the Aspen Steam to convert my process simulation, and now my property package Aspen Steam is associated with component list 1, so I have my fluid package defined. But as I have with the component list, I am able also to add more than one property package. So now what I will do is add a property package based on the Aspen Properties databank. When I click on that, you can see that my component list selection now loads the component list 2, that is the Aspen Properties databank. And I am not able to choose the component list 1. So you can see that when I choose the component list from Aspen Hysys databank, I need to use a property package from the Aspen Hysys databank. When I use a component list from Aspen Properties, I need to add a property package from the Aspen Properties databank. To finish this component 2, I will choose Steam NBS, my property package already converted, and now I will return to the fluid package, and you have seen that we have a third option here talking about property package. So when I click on ConThermo, you can see that the interface changed also, and my component list selection loads to me only the component list 1, meaning that I am able to associate property package with the standard databanks of the Aspen Hysys, with the property package from Hysys, and also with the ConThermo. But what is ConThermo? In summary, ConThermo is an advanced thermodynamic calculation framework based on Microsoft Component Object Model technology. In summary, ConThermo is a tool that Aspen Hysys offers to you if you want to develop your own property package or if you want to edit the existing ones. Most often, we don't use that if we are a regular user of the Aspen Hysys for chemical process engineering and plant design. Eventually, you may use this kind of tool if we are talking about research and development. So the first fundamental is how to use the databanks available on Aspen Hysys. You have seen that you can add components from the Aspen Hysys standard databank and also from Aspen Properties databank. And the components that you choose from the Aspen Hysys databank must be associated with Hysys or Contermo package. On the other hand, if you use components from the Aspen Properties databank, you must combine them with Aspen Properties package. Now let's explore a little bit more about the component list. When you are filling your component list, if we are talking about standard process, most often the majority of your components will be pure components, and you will be able to find them from the Aspen Hysys databank and use the search tool here. However, in some process, we need to add components that are not available in the Aspen Hysys databank. If you are using the Aspen Plus, there are more options for adding hypothetical components to your process simulation, but Aspen Hysys also have some tools or some ways to do that. So to start with, we need to click in hypothetical, and that will open to you two kinds of hypothetical components to you. One of them is creating hypothetical components based on a batch of hypos or hypothetical components. When we choose this option, we just need to inform the initial boiling point and the final boiling point and the interval desired to this procedure. Based on that, you click on Generate Hypos, and the Aspen Hysys will do a list of hypothetical components that you can add to your component list. But there are other options to do a hypothetical component if we are talking about only one component. Let's suppose that I have only one component and not a batch of hypothetical components. So to deal with that, I need to go to the arrow and create and edit hypos. When I do that, change the information that are needed to create my hypothetical components. So my minimal required information changes. First, you can observe that I can change the type of the method, so I can consider the base properties or I can consider the vapor pressure. If I have the vapor pressure of the hypothetical component, I can click on Add New Hypo and inform the temperature minimum, maximum, and the coefficients. And based on that, Aspen Hysys will do the estimation of the properties of the component. But let's suppose that we must define a hypothetical component based on the basic properties. So I need to click on New Hypo, and now I need to add the minimum required information to define a component in Aspen Hysys. And the minimum required information depends on the available information that I have to me. If I click on Estimate Unknown, you will see that to define a component, I need to specify at least a specific boiling point or a specific density and molecular weight. So let's do the verification. If I set a boiling point here and click on Enter and click on Estimate, the Aspen Hysys estimates all the other parameters from my hypothetical component. If I delete the normal boiling point and add, for instance, only the molecular weight and click on Estimate Unknown, the Aspen Hysys gives to me the warning. So I am not able to define a hypothetical component list only with the molecular weight. I need to define also, or to inform also, the liquid density. So let's add the information and click on Estimate Unknown. Based on that, molecular weight and liquid density, the Aspen Hysys do the estimation of the other parameters. The second fundamental is how to deal with hypothetical components on Aspen Hysys. You have seen that you have two ways of defining hypothetical components on Aspen Hysys. One of them is creating a batch of hypos. This way, you need just to inform the initial boiling point, the final boiling point, and the interval that you want Aspen Hysys to consider. Or you can define just one hypo. In this case, you need to inform at least the normal boiling point alone, or the molecular weight and the liquid density of your hypothetical component. With this information, the Aspen Hysys will do the estimations for your component, your hypothetical component, and you will be able to add it or them to your component list. And now that we already talked about the databanks and also about the hypothetical components in Aspen Hysys, let's go to the process simulation environment to talk about the streams. The fundamental number 3 in this video is streams. Basically, Aspen Hysys deals with two kinds of streams: energy stream, represented by the red arrow, and also the material stream, represented by the blue arrow. The minimum information needed to solve an energy stream is just inform the value of the heat flow. If I click 2 times on this stream, you will see heat flow, a blue field. So the blue field means that the user can add information to this field, and I have the black field that means it is an Aspen Hysys calculation. So if I add any value here, click on enter, the green bar means that I have solved this energy stream. Most often, the values for the energy stream will come from other calculations. When we talk about material stream, we need to add more information to Aspen Hysys in order that Aspen Hysys can solve the material stream. So when I click 2 times on that, the minimum information needed to solve the material stream will be the composition, and I have different options to set my composition basis, and the conditions of my stream. So to solve a material stream, I need to inform the flow, and the flow can be molar flow, mass flow, or standard ideal liquid flow, and there are other kinds of flow on Aspen Hysys. So if I inform the molar flow, I need to inform at least 2 of them from phase fraction, temperature, pressure, enthalpy or entropy, and one of these 2 variables that we must inform must be temperature or pressure. So let's verify. If I define the temperature and I define the enthalpy, I define my flash calculations. If I define my pressure and define the enthalpy, I define my flash calculation. If I delete enthalpy and I define entropy, I define my flash calculations. And all of these will lead to the solve of the stream, because besides the properties information, condition information, I have defined the flow. It can be, as I told you, the molar flow, can be the mass flow, or it can be In this case here, as standard, the standard ideal flow. And you see each time that I define a flow, the others two are converted based on the properties of the component. In summary, to fully specify your material stream, you must inform the composition of your fluid. It can be a user input or a result from a calculation in Aspen Hysys. You must inform the flow of your fluid. It can be molar flow, mass flow, or standard ideal flow. And you must inform also for the flash calculation 2 conditions of 5. And it's mandatory to be one of them at least temperature or pressure. And the other 3 that you can define is entropy, enthalpy, and phase fraction. So with all of these defined, your stream is solved and you have the full specification of your material stream. Now let's talk about component properties. In the material stream, besides the conditions and also the composition of our fluid, it's possible to verify the properties of the fluid that we are dealing in our process simulation. Some of these values comes from the data bank available in Aspen Hysys, and others values comes from the calculations performed by the property package that we have chosen. There are some values here that is calculated based on a general model that supports several equations and submodels on Aspen Hysys. What this means? This means that not all calculations related to properties comes from the property package. There are some calculations that Aspen Hysys has specific equations and submodels that independs on the fluid package chosen. In this table, you can verify that Aspen Hysys perform temperature-dependent properties calculations for pure components and only for pure components based on equation from the DIPPR and also some submodels. So in this list here, you can see that there are some properties that is not calculated based on the property package. For instance, we have here the liquid volume, we have heat of vaporization, we have liquid viscosity or vapor viscosity, and liquid thermal conductivity. For instance, all of these calculations are not based on fluid package calculations, but for specific models inside the Aspen Hysys. And with this, we have the fundamental number 4. The calculations for properties is not only a function of the property package selected, but also based on the models and submodels that is available in Aspen Hysys when we talk about temperature-dependent properties. And finally, to finish this video, let's talk about the fundamental number 5. And the fundamental number 5 is that the Aspen Hysys allows you to edit or to change some of the information that is available in the data bank of the software. It's very useful when you are dealing with research and development. Eventually, you have specific data that is not available on Aspen Hysys, so you can use your own data to change some parameters that is available on Aspen Hysys. And now let's go to the process simulation software to verify how it's possible to do this. If for any reason you need to add your experimental data to the Aspen Hysys process simulation, it's possible to setting up a tubular package. What the tubular package does? The tubular package is used in conjunction with a property package that you have selected. So your target properties are calculated as replacements for whenever procedure the associated property method would have used. So you need to choose a property package that allows you to access the tubular package tab. So the Aspen Steam do not allow us to do that. So for instance, I will choose Peng Robinson. When I choose Peng Robinson, now you can see that new tabs are available to me. And if I go to Tubular, now I can enable Tubular properties. If I do that, I can go to options and I will have a list of properties where I can use my tubular information instead of the calculation performed by the fluid package. So if I click on viscosity, vapor and liquid, for instance, it will enable me to add mixing rule parameters. And now if I go to information, I can adjust the way that viscosity, for instance, is calculated in my Aspen Hysys process simulation. This is an advanced technique, so I don't recommend you to deal with this if you don't know what you are doing. Most often, I believe that this kind of feature is for people that deals with research and development. With this, we finish 5 Aspen Hysys fundamentals you must know and understand to perform your process simulation. The first one is related to the Aspen Hysys databank. So based on the databank that you choose, Aspen Hysys standard or Aspen Properties, you will have restrictions to combine your property package and your component list. We have seen also how to deal with hypothetical components definition or creation. There are 2 options on Aspen Hysys: use a batch hypothetical components and also a single hypothetical components definition, and the minimum required information in each one of these cases. Moreover, we have seen how to do the full specification or the full set of a material stream in order that you have all the information converted and available in your process simulation. After that, we have talked about the equations or calculations performed by Aspen Hysys to define the temperature-dependent properties. It's not dependent of the fluid package, but from specific sub-models that is available on Aspen Hysys. And finally, we have seen how you can add your data to the Aspen Hysys. In my point of view, from these 5, the 3 first ones are the most important for chemical process engineers that works with plan design. The 4th is basically information. There are not too much that we can do to change that. There are any kind of intervention that we can do. And for people that deals with research and development or that have specific data to be added to the Aspen Hysys, the 5th or the fundamental 5 can be beneficial to you. Just before I go, let me know in the comments what is the most important fundamentals to you, and if you would like to have more videos like this in my social media. So this is it. I hope you like it, and I'll see you soon in the next video. Bye bye.